we had left over yesterday. Before I even open anything, can somebody tell me what is Ethereum in relation to blockchain, or in general? What do you understand by Ethereum? Tell me, please. What is Ethereum?
Virtual money?
No. See, Ethereum is a public open source platform which is based on blockchain technology. And you can view it as you can say a world computer built on top of peer-to-peer network. This trusted and decentralized applications can be run on top of Ethereum with no threat of centralized management and SPOF. SPOF is a single point of failure problem. And as there is only one such machine in the world, the computation resources such as CPU, memory, all these things is limited and strained under pressure of huge scale of user base and dApps. So it is understandable that using Ethereum world machine will cost money in terms of cryptocurrency. Generally, when you speak, Ethereum is a state machine based on transaction, and the transaction formula can be written as sigma star, this is y of sigma comma t. Here sigma is the transformed state. The initial state is sigma and the transformed state is this, and t means the transaction, and this symbol gamma is the transformation function. Let's have a look at a small little example. See, the initial state is that the account balance of, let's take two people, Alice and Bob. The initial state is that the account balance of Alice is $100 and the account balance of Bob is 0. I take Alice and Bob. The initial status, the account balance of Alice is $100, Bob is $0. Assuming that the transaction is that Alice pays Bob $10. The transformation function sigma is to transfer $10 from Alice's account to Bob's account, and the transformed state is sigma with a dash I put, and the account balance of Alice will be $90 and Bob will be $10. See, Ethereum holds all the features of a public blockchain. The public private key encryption, cryptographic hash function, something called as Merkle tree. We will see it as we proceed, and hard soft fork. And these are all the information that Ethereum holds for you. And there are some technologies and terminologies which you should know as we proceed ahead. The first, we start off with little bit pushing yourself little bit in mathematics. Like I said, anything you do in blockchain, you have to be wonderful in mathematics. Let's start off with what is asynchronized cryptography. See, asynchronized cryptography is the greatest invention of the history in the history of cryptography. See, synchronized cryptography needs to share the key synchronized suggests
Your voice is breaking.
Okay. Tell me, is it fine now? Confirm to me, is it audible
Yes,
and
sir.
clear now? Okay.
Yes.
See this,
Sir.
yeah.
Yes,
I
sir,
said
yes,
this
sir.
asynchronized cryptography was one of the wonderful invention of mankind, you can say. And in asynchronized cryptography, in synchronized cryptography, you need to share the key beforehand itself. And asynchronized means encryption key and decryption key are different, and they are named public and private key. Normally, the public key is open and it's made available to the public, while the private key is usually kept private by the person. Since this public key and private key are separate, it means that the public private key can be used on unsafe channel. One of the asynchronized cryptographic technique we shall see right now, and I shall want you guys to solve this problem for me. One of the wonderful known techniques of asynchronized cryptography is Diffie-Hellman. Diffie-Hellman algorithm. Here, what I'll do, I'll introduce this Diffie-Hellman algorithm, and whoever solves this correctly, we give you 20 marks as part of, you can say, maybe a surprise test for you. Anybody who answers it correct, you get 20 marks. I shall reflect it on the canvas by the end of the session today. In Diffie-Hellman algorithm, we are going to introduce a key exchange algorithm. See, and another thing, friends, these marks are important and I would say essential because for two reasons, what I spoke of at the beginning of the course. Once again, let me repeat it. The first is, see, the top 2 or 3 of you I shall take with me for a project which we are doing for the government of Canada in blockchains. And the second thing is the certificate which will be issued by the college to you will have the joint certification with Brain Tower Oman. And it's a very reputed company. It's about an 18-year-old company in Oman as well as in Belgium. So it is only if you qualify all these things, that is minimum 75% attendance, and you getting at least 60+% of marks overall. You get the assignment, you get the certificate from these guys. Otherwise, if the college gives you, you can take it, but definitely you will not get it certified with Brain Tower Oman. Okay, so we will introduce this Diffie-Hellman algorithm. And here we introduce an operator called as a mod operator. You must be knowing what is a mod operator. Assuming this is simple mathematics. See, assuming that we have modulo A for any given number B. So B mod A is the remainder of B divided by A. B mod A, if I say B mod A is the remainder of when B is divided by A. Now, suppose I use modulo A. If I say, what is 15 mod 11? Can somebody tell me what will be the answer for this? It is simple mathematics. In any case, first semester of engineering, which you do mathematics, that is also not required to know this. Much lesser
15
than
by
that.
11.
What is the answer?
15.
15? No, it's wrong.
4.
11 by
4.
15.
Who told it is 4? It is 4.
I.
Yeah. The other one I shall ask you, 3 plus 8. If I say 3 plus 8 mod 11, what is the answer?
0.
Sir,
Yeah,
your voice
0.
is breaking.
Can others hear me clearly, or is it that I'm breaking for everybody, or only selected few?
No, it's audible, sir. There's no issues, but I think so probably some might be able to.
You might be a problem with your connection. Okay, what is the answer to this? Yeah, I say 3 cap 4 mod 11.
1.
1. No, it's wrong.
4.
Calculate. 4.
4.
It's correct. Yeah, it's 4. That is 3 cap 4 is 3 raised to the power 4 mod 11. Now, after you know this fundamental things, you are ready to build your key exchange algorithm. Please listen to it very, very carefully. Here is the time when your skills are required. I have got 3 people with me, A, B, and C. A and B select their own private number. Now, for the sake of convenience, we assume that A and B both select a small number. Let's say A selects 8 and B selects 9. And in the real world, when you solve any real-time problem, these numbers, what A and B selects, has to be huge number for the purpose of security. Now, since A and B select 2 numbers, these 2 numbers are public numbers. Everybody knows it, what are these numbers. Then what you do, out of these 2 numbers, 1 second, one of the number I shall call it as modulo. The other number I'll call it as radix. So in this thing, since A and B share, say, let me say 11 and 2. Let's presume that A and B share 11 and 2. So this becomes 11 mod 2, where 11 is, what is 11? 11 is the modulo, and 2 is the radix. So 11 mod 2. What is the answer for 11 mod 2?
1.
1. Yes. Okay. Now A and B build their own PPN, that is public private network, or public private number. I'm sorry. Now A and B will use two shared numbers in the previous step with their own private number to calculate their PPN. And PPN is given by the formula. PPN is radix cap the private number mod modulo. This is how PPN is written. So what happens? I shall rub clear the screen. If you have written this formula, PPN is radix cap private number mod of modulo. After this, what happens? A and B mingle the other party's PPN with their own private number. This method of mingle is very similar as what to the one which we have discussed above. Just what you do, you replace the radix with PPN. That is, in the previous example, I'll say A's PPN will be 2 cap 8 mod 11 and B's PPN will be 2 cap 9 mod 11. Whatever answer, 2 cap 8 mod 11 is 3. 2 cap 9 mod 11 is 0 2 4 6. Now, as this calculation process is irreversible, you cannot reverse this calculation process. Now, A and B mingle the other party's PPN with his own private number. And this method of mingle is very similar to what we had shown here, just this example. Just what you do, replace the radix with PPN. So what becomes A's share key? A's share key will be B's PPN cap 8 mod 11, which is nothing but 6 cap 8 mod 11, which becomes, what is 6 cap 8 mod 11, whatever the answer. And what becomes B share key will be A's PPN. A's PPN cap 9 mod 11, which is 3 cap 9 mod 11, whatever the answer. Somebody tell me this answer and this answer. So this way you find the reason why we get this. Now in this, both the thing, whatever answer you get here as well as here will be the same. The reason we get the same is because the power operation satisfies the commutative law. And you must be knowing what is commutative law. Commutative law says that A cap B cap C is nothing but A cap C cap B, which is not, once again, is nothing but A cap BC. This is commutative law. Now A and B get the final share key, which is this answer. This is the final share key through this mingle process, and A and B can use this share key to encrypt or decrypt. Now there is another one new person in this, like we have considered only A and B. What about my friend C? C is an eavesdropper. Eavesdropper is a person who tries to steal the information. Now he wants to steal this key, what is used by A and B. C cannot get A or B's private key, even though they know A or B's PPN. C cannot get the final share key through this mingle process. This is what is Diffie-Hellman key exchange. Now, you please do one thing. Take two of you, any two of you, share your key. That is, or this way can be, although this algorithm is a little old algorithm, but it is extensively used. You can use this when your college, say, shares the marks with Osmania University. Encrypt the marks using the shared key, which is this key as well as this key. And at the other end, he decrypts and he comes to know what are the marks. Because even the technique which is followed in RSA algorithm is more or less the same. You find the modulus of huge numbers. When you find the modulus of very huge numbers, it is practically impossible for anybody to find out what are these huge numbers. And the share key is out of question for you to find out. This is what is Diffie-Hellman algorithm. Did you understand what it is? Who is the person who can claim that person has understood? You are quite a lot of you. It cannot be that you have not understood. There are 24 of you who are here. So definitely I feel you would have understood what. Who has understood what have I told? Tell me, if you don't speak out, I'll not come to know. Who wants, or do you want me to tell you once again? See, this is the basis for, or the fundamentals for what we are doing in this whole of this course.
Sir,
Once
please
again,
explain
sir.
once again, sir. That will be very helpful.
Okay. Yeah. See, we are seeing the most fundamental algorithm, which is very, very essential for us to do anything on blockchain. I had asked you what is 15 modulo 11. You told it is 4. It is fundamental mathematics, which is taught in first semester of engineering anywhere in the world. Now we are, I would say we are wonderful and ready to build this key exchange algorithm. This Diffie-Hellman is a key exchange algorithm. So in this, to build this algorithm, I'll consider 3 people, A, B, and C. What A and B does, initially A and B select their own private number. Ideally, the private number that they select would be a prime number. Prime number. That is the catch in this. And this prime number which they choose would be a huge prime number. Let's presume A select in this 11 is called the modulo and 2 is called the radix. Now what both of these people do, A and B build their own private public private network. The first step is you choose 2 prime numbers. Although I'm taking 2 small numbers, it has to be huge number, very huge number, and you take a prime number and then you find the public private network of this. You A and B build the public private network. The formula to build the public private network is radix cap private number mod modulo. This is how you build the public private network. So in this case, what becomes ACE PPN? ACE PPN becomes 2 cap 8 mod 11. When you solve it, this you get it as 2 cap 8 mod 11 is 3. Then B's PPN, this becomes 2 cap 9 mod 11. Now you might be thinking, where is this 8 and 9 has come? Let's presume initially A selects a number 8, B selects a number 9, right? And these two are their private numbers. 8 and 9 form their private numbers. Then once again, A and B selects 2 numbers, which are their public numbers, which is made available to the entire public. So using this, A selects 8, B selects 9. So that's why it's 2 cap 8 mod 11, 2 cap 9 mod 11, which is nothing but 6. Now in this process is irreversible because you're finding out the modulo operation. Now what they do, A and B mingle the other party's PPN with their own private number. And the method of mingle is very similar to what we have done here in this example, except that you replace the radix with the PPN. So what I'll do, I'll say what will become A's share key will be B's PPN cap 8 mod 11, which is nothing but 6 cap 8 mod 11, whatever the answer. And what becomes B's share key, SKL, right, for share key will be A's PPN cap 9 mod 11. This is nothing but 3 cap 9 mod 11, whatever answer you get. What answer you get here and here will be the same. It cannot be different. It will be the same. And the reason why this will be same is because it satisfies the commutative law. And you guys know what is this commutative law. To mention this commutative law, if I say A cap B, this whole thing cap C is nothing but A cap C cap B. This is nothing but A share key. Let's presume the answer which we get over there is 4. The same key 4 through this mingle process. And A and B now can use this share key 4 to encrypt and decrypt the message. Now our eavesdropper who is there over here, person C, cannot get A or B's private number even though they know A or B's PPN. C cannot get the final share key through this mingle process. So who can claim that who has understood this? It is a little tricky mathematics. It is not difficult. It is difficult if you have not done your first semester properly. Who can claim that you have done, you understood? And although I may explain, understood.
Sir, understood, sir.
Saida, can you explain it to everybody? What have we told? You can speak out that way. It's from your mic itself.
Yes, sir. We have here 2 persons. One is Alice and the other is Bob. Initially, they two are selecting a number, public number. That will be 11 and 2. 11 is mod and 2 is radix. Then at the same time, Alice and Bob, A and B, are also selecting their private numbers. Here A has 8 and Alice has 8 and Bob has 9. After that, they are going to calculate the public private network. So that we calculate using the formula radix power private number, then mod of modulo. They get their respective share keys, that is 4 and 4. Here we are using the commutative law. It is satisfying the commutative law 4 and 4. So that means 4 is the shared key among Alice and Bob, and C, whoever the C is, the third person, cannot access this key, cannot intervene.
Correct, very correct. I hope you must have got it. So Saida, we give you 20 marks for this wonderful understanding of this. No problem. I shall mark it at the end of the session. Okay. Now what you need to understand, the next thing is, what are these concept of public and private key? See, Alice holds public key and private key. She can utilize private key to generate a digital signature. Since Alice's public key is available to the public, Bob uses this Alice's public key to verify that a Bitcoin address. It is a long hexadecimal string which starts from 0, X, and a lot of alphabets and numbers are there. This is the public key, while this private key may be stored somewhere else. Could be on the cloud server, or could be on personal device such as mobile phone or personal computer. Now, if you lose the private key of your wallet, which means that you lose all the fund in the wallet permanently. So it is always better that you keep a backup of your public key and private key, and not on a computer. You keep it at such a place where it is safe, and you are prevented from any eavesdropper picking it up. Then you need to understand on what are cryptographic hash function. See, cryptographic hash is a hash function, and it takes message as input and returns a fixed size string. The result string is what is called as hash value, message digest, or digital signature, or digital fingerprint, or digit, or checksum. And hash function must have 3 main attributes, and I shall just list it down. What are the 3 main attributes any hash function should have? The first is the hash function should be easy to calculate. That is, using hash, and the whole calculation process should not take too long. It is unacceptable if the hash value calculation takes maybe days. The second is this hash value should be irreversible. Now, if the hash function result is already known, it is very hard to get source text through reverse calculation. For example, say you have a movie ticket, but it is very difficult to fake one. And the third, this property of this hash function is it should be collision resistant. Collision resistant. See, different messages have different hash value. See, an analog is that A and B both say pay 10 US dollars to buy movie ticket, and seat number should not be the same. That is what is collision resistant. So the other thing what you need to know is on what is an EVM. These are all the building blocks for our big journey, EVM. EVM is nothing but Ethereum virtual machine, where a user can develop a myriad apps, means multiple apps he can develop. And compared to this Bitcoin script language, EVM provides more powerful and complete programming language. For every opcode which is executed on EVM, it will be run on each node in Ethereum network. And you also should know what do you mean by a node. Running a node means that user can access on-chain data through the node. A full node downloads the whole blockchain, while a light node does not download all the data and connects to a full node to download desired data from it. Full node can be a computer running all necessary software, which includes maybe this full distributed ledger and P2P routing software. Then you need to know what is a miner. Miner is something which runs a node mining for network, which processes the block on blockchain. Usually the miner maintains a full node running professional mining software, but not all full nodes are mining nodes. If there is a code upgrade, mining node needs to upgrade its mining software with up-to-date code, which can be done through a soft fork, which is a backward compatible implementation. Then one more common third term which you keep hearing in blockchain is DApp, D-A-P-P, which stands for decentralized application. See, in the Ethereum community, the application which uses smart contract are called decentralized app. And using this DApp, you can add user interface and some extra functions to your smart contract, such as maybe this IPFS. DApp can also be run on a centralized server if that server can interact with Ethereum nodes. DApp can connect to Ethereum node to submit transaction and retrieve interested data. Besides a typical user login system, user has a wallet address and data are saved locally, which is different with current web application. And for all these things, we will be using Solidity as our language, which is an advanced programming language based on smart contract. And it has similar syntax as JavaScript. Tell me one thing, have you guys done JavaScript as part of your course?
Yes, sir.
Okay, so it is pretty similar to JavaScript, and it supports static types, integration, library, and composite user-defined types. This can be compiled into EVM assembly and therefore can be executed on all Ethereum nodes. There are other smart contract programming languages. Undoubtedly, Solidity is the hottest, most popular programming language for smart contract, and we will also use Solidity. Now, let's get into what is a smart contract. See what is a smart contract, thereafter build a small little smart contract. Smart contract, as the name suggests, is an automatic contract. And anywhere where in India also we are, government of India has come out with many cities being termed as smart city. All the cities would in due course of time get into smart contract. This is an automatic contract. In fact, smart contract is a computer program which runs automatically when specific conditions is satisfied. Smart contract is a set of instruction which is developed by Solidity. Solidity programming is based on a wonderful concept of, let me just clear up this canvas. See, Solidity programming is based on a concept of IFTTT, which is if this, then that. This is the logic on which Solidity programming language is based on, and it executes code if some condition is met. Since this smart contract is run on Ethereum virtual machine, it cannot access network, file system, or other processes running on EVM. Smart contract can access external data through Oracle if it is required. And generally, smart contract can be implemented on two types of system. Either you can implement it on virtual machine, which is Ethereum, or you can execute it on Docker. And all the following content include discussion. One very important thing when you speak of smart contract is gas. It is written in caps, GAS. Gas is used to measure how many steps a transaction will need on Ethereum virtual machine. It is straightforward. Your transaction is complex, which means it needs more computation resources such as CPU time and memory. You will need to pay more gas. All these opcodes on EVM will cost gas, and it is unlikely to change in the future. The smallest metric or the smallest unit or measurement for gas is WEI. And 1 Ethereum, if I say 1 Ethereum is nothing but 10 to the power of 18 Y, or which is nothing but 10 to the power of 9 Y, GWEI, Y. Gas price is nothing but the gas unit price. And gas limit, minute you hear, please understand this is the upper bound of gas which user is willing to pay. So at least I shall request you, all those who are interested may just write down all these important things. These are very, very essential. Gas price is the gas unit price, and the gas limit is the upper bound of gas which user is willing to pay. And when you multiply the gas limit by the gas price, that is, if I say gas limit times gas price, this is the maximum fees that the user is willing to pay. If in one transaction, if the maximum fees you specified is not used up, then the fund left will be returned to your account. And once this gas is exhausted, the transaction will stop at whatever it is, and an out of gas exception will be thrown, and all state changes made by the transaction will be reverted. But once your fund is used, even though the transaction fails, user will not get refunded since the fund is rewarded to the miners. User needs to pay fee for using computation resources, and this fee which the user pays consists of three components. This is the user fee which the user pays, consists of three components. The first is the computation fee. The second is the transaction fee. And the third is the storage fee. This transaction fee is the contract creation or message call fee. And the storage fee is memory, account, or contract data storage fee. Now, if your contracts save data to the database, all the nodes in the Ethereum will do the same, which is very, very costly. This is why Ethereum will charge for storage, and it encourages less storage usage. Now, if the op is to clear the storage item, Ethereum will do it for you for free or even get refunded. Now, if you want to see the chart about average gas price, you can please visit this website, https etherscan.io. This will tell you the chart about average gas price. Now, the big question is, why do you need this gas? See, generally speaking, there are three main reasons why you need gas. First, it can be for finance. Second, for theory. And third, computation. See, from the finance point of view, the purpose is to incentivize miners to execute transaction and smart contract by using their own time and resources. Many complex operations need more computation resources. That is to say, they need to pay more gas. If a user wishes to have their transaction prioritized, he can submit transaction with higher gas price. And in this way, transaction could be processed sooner by miner, incentivized by higher transaction fee. Now, as the compensation for computation resources which miner invests in gas, say, becomes more crucial after consensus migrates to proof of stake. In this proof of stake era, miner no longer gets rewarded by mining blocks and packing the transaction. It is more important for miner to process transaction and get paid for expending resources on the blockchain. Now, when you see all the components of gas, gas has got three components. Let me open a new sheet for you. Yeah, gas has got three components. The first is the gas cost. The second is the gas price. And the third is the gas limit. In Ethereum, the calculation formula of transaction fees is very, very simple. I'll say my transaction fees is nothing but actual gas cost times gas price. Say, for example, if a transaction, say, will need 50 gas to complete, under the assumption that the gas price which is set by the user is 2 gwai, then the total transaction fees will be 50 into 2 or 100 gwai. Gas, now we also need to understand what is the gas cost. What we have now seen was the component of gas. Let's see the gas cost. Gas cost indicates that each opcode needs how much gas, which is predefined in this Ethereum yellow paper. For example, additional opcode needs 3 gas, regardless of the fluctuation of the ether price. The gas for each opcode will not be changed, and that is why gas is used to estimate the cost of a transaction instead of ether. If at all you use ether for the gas cost, the price might vary sharply. There are chances that it varies sharply. One other term which is very essential, till here are we comfortable? And you are at liberty, you can stop me whenever, ask me to repeat, no problem. Please do not wait for me to ask you if you have understood or not. Whenever you want, you can come up, tell me, stop me and ask me to repeat it for you. Or worse come worse, you're not able to hear clearly, there's some disruption, please come up and let me know. Okay, so the
Sir,
other
what is
thing,
opcode?
okay, you tell me what is that, what do you mean by opcode? Is the operation code. Opcode is nothing but an operation code. This is an instruction which this is an instruction machine code, instruction code, or you can even say instruction syllable, instruction parcel, or even you can call it as op string. This is what is an opcode.
So gas is used in finance, theory, and the other was? Three
Gas is
places you
used.
said.
No, okay. I said there are you're talking about components of gas. See, gas has three
No, sir.
components.
Before components, you said finance, theory, and one more. Gas is used.
So where we
Computation,
need gas.
computation. It is used in finance, theory, and computation. Saida, I said it is gas. Gas is used in finance, theory, and computation.
Yes, sir. Thank you.
Okay, okay. So another one very important thing for you to know or understand is what is an ether. Ether is a token issued on Ethereum. And ether is represented as capital E, capital T, and capital H. It is the short symbol for ether. And ETH is a tradable cryptocurrency. And in Ethereum, ether is mainly used to pay transaction fee. And the transaction fee equals to gas cost multiplied by the gas price and is paid in ETH. And user can set the gas price. But please bear in mind that if the gas price is too low, it is possible that no miner is willing to pack the transaction. Okay, so now I would say we are at bang on
Sir,
place.
please once again say what is ether.
Okay, fine. See, ether or ETH is a token which is issued on Ethereum. ETH is the short symbol for ether, where ETH is all in caps, and ETH is a tradable cryptocurrency. In Ethereum, ether is mainly used to pay transaction fees, and the transaction fee is nothing but it is equal to the gas cost multiplied by the gas price, and it is paid in ETH. User can set the gas price, but the problem is if you set the gas price too low, it is possible that no miner will be willing to pack the transaction. Fine. Now, after doing this, we are at bang on place to write our first smart contract. Let's look at a simple smart contract and how does a solidity contract look like. So for you, what we shall use is you can do one thing, Google it. Solidity I will be using Solidity. I'll use Solidity IDE. As on today, we will for all our examples use Remix IDE. You can kindly open this and let's write a small little smart contract. Solidity, fine, not an issue. Click on the top one, click on contract. If you want one new contract, I shall open. Let me say test. I shall open test. My test is ready. This is an online IDE. Or the other option is you can download this Ethereum Remix Ethereum. But why download it when an online version is available? You can open this and let me know, please. Once you opened it, let me know.
Yes, sir. Open.
Okay, what about others?
To opening this, what do we need to do?
Nothing, just wait, I'll tell you. Done. Have you opened? See, what I'll do, I'll write a simple smart contract. But as of now, I'll not explain to you what is what. It does not mean I will not explain to you. Definitely, I'll explain to you all the bits and pieces of this. It is just for the sake of you having a first-hand exposure to what is a smart contract. A very small little smart contract. I'll write an example smart contract. You can copy down the same thing. In subsequent classes, we will definitely explain all these things, what these things are. It starts with Pragma, and it is more or less similar to JavaScript. Pragma solidity, I'll say 0.4.20 and semicolon. I'll give a space after Pragma solidity. Yeah, semicolon. Then I say contract. Let me say basic token and a curly brace, unsigned integer 256. Let me say of total. See here, all this caps and sentence case, all these things are very, very important. One small mistake and it will not execute for you. And then I say mapping of address equal to unsigned integer 256 and balances. Thereafter, I say use my constructor of this unsigned integer 256 space underscore initial supply. Make this public, and then I say what is my total supply underscore this would be equal to underscore initial supply and a semicolon. Then I need to find out my balances. I say balances of this MSG dot sender. This would be equal to underscore initial supply and a semicolon. Close it with a curly brace. After this, total supply, and this would be public view returns of unsigned integer 256, and we will return our total supply. Return our total supply underscore semicolon, curly braces open. Then after I have, this is a basic simple token. We will explain this, what these things are and why is it is over here. After this, what I do, I create another function. I say function balance of, which will be of address and underscore owner, and this will be public view returns of unsigned integer 256 and a curly brace. We return balances of underscore owner and a semicolon over here. Close my curly brace. Then we define another function. We say function transfer of and unsigned integer 256 underscore value of public returns bool. The boolean, I take this and a curly brace. Then I say require underscore 2, which is not equal to address of 0. Make it semicolon require of underscore value which is less than or equal to balances of msg dot sender, close and a semicolon. Then we need to find the balances. This is simple. It's a simple, basically an account, basic account, simple account. See where I'm finding out the balance, then the transfer of this account, nothing big I'm doing here. Then I say balances of msg dot sender. This would be nothing but balances of msg dot sender minus this will not be minus, this thing would be equal to underscore value and semicolon, and balances of underscore 2, this would be nothing but balances of underscore 2 plus underscore balances of underscore 2 plus underscore value, semicolon, and we need to lastly return true, and then curly braces. Let me just compile this and see. Compile this test dot in line number 5. Line number 5 is constructor unsigned integer 256 underscore initial supply, and here I need to give a space, public curly brace. Expected and got constructor initial supply, constructor spelling of constructor TRUTOR unsigned integer 256 underscore initial supply of public. Let me give a space and see. No, there is some other error. No contract yet compiled. Is there, have we missed out on something? Total supply underscore equal to underscore of initial supply. That's fine. Mapping of address equal to string unsigned integer 256 balances semicolon, and here unsigned integer, just small little problem, space and other things, small issues only. It does not see, the structure is more or less the same. There's some small mistake here or there, that's it. Contract is the basic token, Pragma solidity 0.4.20, contract basic token, unsigned integer, total supply underscore colon mapping of address, unsigned balances, constructor, RUCTOR. And are you guys also getting the same error or some other error?
Same error, sir.
Constructor unsigned integer 256. And doesn't this resemble JavaScript to a large extent? Tell me, since you have told me you have done JavaScript, doesn't it resemble JavaScript to a very large extent?
Yes, sir.
But it is different.
And all returns. Yes.
Yeah. But see, as we proceeded, when we write more and more of program, you'll find this differs to a very large extent. It differs. Let's see this 1 second. Constructor unsigned integer 256. Let me rewrite this sentence again. Constructor of unsigned integer 256 underscore initial supply. Then I take public expected identifier got L parent constructor unsigned integer 256 uint 256. There is some other error which is being carried. Basic token uint 256 total supply underscore mapping address uint 256 balances constructor. Okay, it says it is finding an error here in line number 8. What is this? Initial supply semicolon and close balances of msg dot sender. This is equal to underscore initial supply. This says this is the error. This constructor is the error.
Sir, are we
Yeah.
supposed to be parameter in constructor?
No, nothing. It's fine. There's some small little mistake for which it is giving us trouble. Just a second. Pragma solidity constructor and map contract basic token. Okay, and uint 256 total supply underscore mapping address uint which we map it to unsigned integer 256 balances constructor uint 256. Read out the error. What is, you can just check transaction data and start debugging, execute JavaScript. 1 second. It's giving us trouble on this. Wait, returns pool. Anybody getting some other error other than this? Function total supply, public view returns. No, there is an error here itself.
Maybe the version of solidity.
No, it's always the latest. When you run online, it is the latest. That's not a problem. In the file explorer, click run. One
Sir,
second. Yeah, tell me.
For a second, can you try 0.4.22?
Yeah, compiled. Change the compiler. Instead of 0.4.20, take it as 22, the latest one. Done. See, click on compile, you will not get it. After this publishing of it, we'll see later. Don't worry. You can publish it on Swarm, IPFS, compilation detail, all that fine, no problem. This is a very simple smart contract. You can say the first of the smart contract which has been developed by you yourself. This is a typical token contract. What we will do, we will not dive deep into details at the moment and just pay attention to the program structure itself. Now, if you have some object-oriented language background, you can find that there is no big difference between Solidity and traditional programming language such as C++ and Java. There is a Pragma keyword. which is a compiler directive that specifies the compiler version to be used for the current solidity file. And there is a class and its name is basic token. And the contract can be seen as the class in C++ language. There is a variable declaration, which is unsigned integer 256 mapping. There is a constructor. There is a function. There is a parameter and return value. There is also this if else over here, which is almost the same as that in Java or C++. Fine. Have you done this, completed this?
One minute, sir.
Yeah. Just change that Pragma solidity point from 0.4.20 to 0.4.22. Let me know after you have done. Let me know, please, if when you're completed, you are able to compile it without errors. You need not worry about what is written here, how is it written. Subsequently, I shall explain to you how do you create the smart contract. What goes inside creation. Now it's just a glance at how a smart contract looks like. All those of you who are using a mobile and listen to this commentary, how would you try execute this? You can please do this code, that is the screenshot of this what you have written. Put it in your lab record. I shall also write it down and keep that this is the first lab experiment of yours where you have created a smart contract. A simple smart contract you have created. Let this be the first lab experiment. I shall also make a mention of this and keep. Finally, when you submit your lab record at the end, it should contain this. Have you completed?
Last two lines, sir.
Yeah.
Excuse me, sir.
Yes.
This
sir.
regarding the lab record, is it a specific thing, something, or just we can have a PDF there we can store the screenshots and all?
That's that.
So you're not audible, your voice is.
Compile all these experiments. Is it fine now? Tell me,
Yes,
Saida,
yes,
is it
sir.
fine? Okay. I said, see,
Yes, sir.
maintain a record of all this. When we say it is an experiment, put it in the lab record, and finally you need to give me a PDF version of this. But with each of the one, which it needs to be beautifully numbered. That is you need to tell this as experiment or your lab session 1, and the aim of this thing is creation of a simple smart contract using Solidity. And what is that you have done using Solidity? You have created a simple smart contract. Take a screenshot of this, put it in that, and finally as an e-record only. I don't want a physical copy.
Okay, sir.
Please write it for yourself and execute this, compile this, and see if you're getting any errors.
Done, sir. No error.
Okay, fine. Others, have you done it?
Yes, sir. Done from my side too.
Okay. Now what I'll do, I'll just go back to Canvas. Let me show you something else. Okay. See, the next concept you need to know is how do you test the local Ethereum node? To test the local Ethereum node, you'll be using Ganache. 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 You'll be using Ganache, which is a local Ethereum node for testing purpose. Ganache is a local Ethereum node which is used for testing purpose. Ganache was called test PRC earlier. So some earlier old books you take, it might be called as test PRC. It is nothing but Ganache. You need to install Ganache, and at the command line, you please do one thing. You type this npm install -g Ethereum JS -test RPC, and then you call test RPC. It will install Ganache for you. Or you can do one thing, you can directly also install Ganache, for which what you need to do, you can just type sudo npm install -g Ganache -CLI. You will be able to install Ganache. It is, once again, understand, it is the local Ethereum node for testing purpose. Fine. If you have written this,
Sir,
I'll
it is
just
for
change
Apple,
over.
right?
Yeah.
So we have to search.
Now there is another one more thing which is called Truffle. If you have heard of this, otherwise I shall tell you what is Truffle. Truffle is an outstanding development environment, testing framework, and Ethereum resource management channel. And it makes development on Ethereum much easier. Truffle has got some wonderful functions. It has built-in smart contract compiler. It has got linker. It has got development and binary file management. It has got a console which interacts directly with the smart contract. You can either use Ganache or even Truffle. You can install this and you can see how this thing looks like, Truffle and Ganache. Okay, now what we will do, we will introduce this concept of remix. We have all this while we have used this remix Ethereum ID to compile our smart contract. What has been written there? Don't worry. We will now introduce remix, where I'll tell you what is that has been written. We will use two smart contracts to introduce remix. The first smart contract I call it as callee, and the second smart contract I call it as caller. Callee is the contract being called, and caller is the calling contract. So what we shall do, we shall write a smart code for the callee and caller. Callee, let me, I shall, so let me write a small little code in a solidity for callee. I need to write Pragma solidity cap 0.4.24, and then I to 4.24. Oh, what happened? Pragma solidity cap 0.4.24. I say contract callee. I open my curly brace. Then I say unsigned integer, and then we say public values semicolon, and I say function get value of unsigned integer initial, and what we will do, we will returns unsigned integer. And once again, let me have a curly brace, and I need to return my initial plus 150 semicolon. Okay, and curly braces. Then once again, I create a function which I shall call as store value of unsigned integer value, and have a curly brace. I say values dot push of my value, and a semicolon, close my curly brace. Then again a function which I say get value, and I need to this thing returns of unsigned integer, and I have a curly brace, and I returned values dot length and a semicolon. This is the source code for callee. Let me compile this. Okay. Expected Pragma import directive distinction. Okay.
Sir, solidity space.
It's
Pragma
okay.
solidity first line.
No, that's okay. That's 1 second. 1 second. That's okay. Function, 1 second. Function get value unsigned integer uint initial returns uint expected Pragma import directive. It says contract callee uint public values function get value. It's correct. Oh, it is not unint, it is uint. My mistake. Still, oh, expected Pragma solidity cap 0.4.24. So 1 second, what else has gone wrong? Uint unsigned integer public values function get value uint initial returns uint return initial plus 150. Yeah, that's fine. Again, some small little chaos. 4.24. It's still giving me error in callee. Function get value. This is the problem. One small error, and the whole day you spend hunting for the error. Function get value uint initial returns unsigned integer, and okay, return initial plus 150 appears to be fine. Any other error somewhere else? Just have a look at this. Pragma solidity cap 0.4.24. I feel what I have missed out is values dot push of value, values dot push of value, dot push of value semicolon, and return values dot length. That problem has got sorted out. Now another new problem. Functions.
Sir, values, public values. We have used values,
Sorry?
not public values. You int public values. Returning only values. Is it public value or only values?
Which line are you talking about? Line number 11?
8, 11, and the third line.
You int public value. That is fine. The third line is correct. Public values it is. Initially, I make this values as public, and in line 8, values dot push of value. That is also correct. Push of value.
Sir, we haven't initialized values yet, sir. Values is not initialized.
One second.
Or is it a built-in function values?
No, it's a built-in function. You need not initialize value. It is a built-in function. That don't worry. That's not at all a problem. That's not a problem. Values dot push of value, and the other one is return values dot length. That's also fine. Function get values. Function store value. Here it is get values. Okay, get store values, returns unsigned integer. Uint, and the top is uint value. Values function store value of uint value, and values dot push of value.
Sir, in get values, try uint value.
One second. There's a problem with this function. This functions, one second, let's rewrite this whole of this function. Function store value of unsigned integer, unsigned integer value, and give a curly brace. Then we say values dot push of value. Let me try this as values. Now this problem with this curly brace in 9. When I've opened it, I have to close it. Here, and here. This is
semicolon and values dot
semicolon. Push. Yeah. Push dot value semicolon. Now in 12.
Sir, there is an extra closing bracket, flower bracket on 11.
No, this is for this closure of 7. 7 is a 9, okay. This is an extra one. Now the problem with 8. Did you mean values push of you mean values dot push of dot, well, it is values dot push of value, it is, and uint values dot push of value. Some small mistake, just some mistake or some sign somewhere. Function store value event of value. This should be value, not values. Function store value unsigned integer value of this thing, curly brace, values dot push of value. I'm fed up with this. Let's write this again. No problem. What we will do, we will first write the caller contract and then we'll write the callee. To write the caller, we say Pragma solidity cap 0.4.24. Then we say contract caller, and then a function some action address ADDR, and I need to say returns of unsigned integer close and my curly brace, and then I say callee C equal to callee ADDR semicolon, and then I return C dot get value, let me say of 100. Again a semicolon close. Let me just execute this part and see. Again the problem here, callee C equal to callee, if I reduce the space, no, it has to be a space here. Function some action address ADDR returns uint the same, okay, and callee C equal to callee of ADDR semicolon return C dot get value 100 close, and this again it has given undeclared and identifier not found nor unique, callee C equal to callee ADDR. Oh, CALLE, yeah, the spelling is correct. Identifier not found or not unique, callee C equal to callee ADDR. Because we are not declared callee, that's why it is giving me trouble. We have to first define our callee. After that only you can do this. Chalo, go back and do our callee. I say contract callee and unsigned integer unsigned integer public values and function get value of unsigned integer initial returns unsigned integer curly brace, and then I say return initial plus 150 semicolon. Try this. Yeah, till here fine, but it gives me a warning at 4. What is the warning at 4? Function get value uint of initial returns uint it's just a warning which I get on 4. It's okay, we can go ahead with this. Return initial plus 150. Okay, after this what we do, we specify function store value of unsigned integer value and values dot push of value. In this line, values dot push of value, values dot push of values dot push of value. Now it's giving me an error. Undeclared identifier. Did you mean value or values dot push of value? Value dot push of, the error is in line 8. Values dot push of value. The error is in this. Fine, it's just with a warning. Then after this, one more, I say function get values returns unsigned integer. Then we return values dot length. Values dot length. Closure. This is fine. Undeclared identifier dot return values dot length. Return values dot length. The only error is now in the last line. Just this last line, line number 11 is the small little error, what we are getting. It is correct, return values dot length and semicolon. That's very correct. There's no, absolutely no error in this. See, this is the contract callee, and you need to create a source code for caller contract. Now, after what you do create these two, you go to this remix.ethereum.org, copy and paste the code to remix, and then deploy and run the you compile this, then deploy and run it. Not an issue, don't worry. We will have many more opportunity to create many more contracts of this kind. This is just an introduction which I'm giving you on what these things are. It's not an issue that you're having any problem, not an issue. See, there is another one more wonderful thing called Metamask. I shall introduce this concept called Metamask. Metamask, like what you have seen earlier, is a browser plugin, and it plays a role of both this Ethereum Explorer and wallet. Through this Metamask, you can interact with dApps and smart contract without downloading software or the blockchain. And instead, you only need to install plugin and create wallet before you can start to transact, send or receive order. The biggest concern of MetaMask is just like other online wallets. You must trust MetaMask since all the information is stored on it. While it is possible that sensitive information is hacked or leaked, for you to install MetaMask, you go to your browser, you type https metamask.io. It's a browser extension. It's a wonderful extension. Don't worry. And check on that where that you need to add it to either your Chrome or Firefox or wherever. It's a wonderful trusted extension. See, the main function of MetaMask is to deposit and transfer cryptocurrency. There is another one more wonderful thing for which you should know before we do anything else, which is called MIST. MIST is an application based on Electron, which means it is a desktop application with web interface. MIST includes a Geth node on the background, and MIST connects to Ethereum blockchain, and its address where you download MIST is, you can download it from this site, https github.com/Ethereum/MIST. You should be able to download MIST from here. Yeah, you can download MIST from this thing. It's a one, if you can start MIST with no parameter and it will start up as an internal node. And there are some other tools which you can use, but we will stick ourselves to this Remix ID Ethereum. We will do our programming and the other thing using Remix, because Remix is wonderful, and we shall stick on to Remix. Now coming to the first line of code which we have all the way written over here, that is this Pragma solidity cap 0.4.24 or whatever this thing you write. This means Pragma indicates that the compiler version anything above 0.4.0 should be used as compiler. You should be used to compile the Solidity source code. This cap which I've written, the small little cap before the 0, means that the compilation does not work if the compiler version is earlier than 0.4.24. You can also specify the compiler version range. What you can do, let's go down to 0.20. Now compile it. The earlier version, maybe instead of 2.4, let me make it 0.20, compile it. One of the earlier version, it should compile, no problem. Don't worry about that. This cap is that anything before this will not execute. Then what you do, then the other thing is, the next what you write is import. That is after this Pragma solidity, after you write this Pragma solidity whatever, then you write, then the next when you create a smart contract is import star as symbol name from whichever the file name. This means what it does, it imports it separately. And in Pragma, to write a comment, it is either // if it is a single line comment. If you need to write a multi-line comment, it is / and star. Right? Comment. And if you want to write a document comment, you can use // or / and 2 stars, however you want, whichever. And this format is what is called as Doxygen format, DOXYGEN format. This is a Doxygen format or Doxygen syntax. Okay, and in contract, when you write a contract, let me see. See, when you write a contract, you must have seen that after you write this Pragma solidity, I say cap 0.4.11. Let me write 0.4.11 semicolon. Then if I write my contract which I'm doing is, let me say it's a contract example. A curly brace, I'll first use unsigned integer 256, which will be an object. I shall come to this, what I'm writing and what is being written here. Then I say function set object of this unsigned integer 256 underscore para, and then I open a curly brace. I specify what is my object, which is nothing but underscore para, semicolon. Close my curly brace. Then I create a function which I say get object and returns, I'll say unsigned integer 256, curly brace, and then we return the object over. In this, see, for all those who are familiar with this object-oriented programming, it is easy to understand that the contract can be thought of as a class. Contract also has a constructor, a member function, and member variables. And the next thing what you write in a contract is a library. See, the main difference between library and a contract is that library cannot use fallback function, payable keyword, or define storage variable. However, this library can modify storage variable in the contract which invokes it. Now, for example, if you call a function in library from a contract and pass the storage variable defined in the contract to the library function as a parameter, what will happen? The variable can be modified in the library function and the change will be reflected in the calling contract. You can think of this as, say, passing a C pointer to a C function. A very simple example. Now, beside, library does not have an event log, but event can be emitted by library. Event triggered in the library function is recorded in the event log of calling contract. Then we have got an interface. See, interface is what we have written over here. Let me say, if I write Pragma solidity, this one 0.4.11, then I write interface as this. Let me say my interface is xxx, my curly brace. Then I say my function cal, which I say unsigned integer 256 para, and I say my external view returns of unsigned integer 256. Close it with a semicolon. See, like Java, C++, Solidity interface just defines prototypes instead of implementation. So any contract has got, smart contract has got 6 parts. The first is the state variable. Second, the structure definition. The modifier definition. Fourth, the event declaration. Fifth, the enumeration definition. Sixth, the function definition. These are the 6 parts in a contract. We shall see all of them, but not today, maybe the next session when we catch up. Till here, anybody has got anything to ask me with regard to what we did? Yeah.
I have removed the error from calling.
No problem. Small, I told them small little typo error. What was the error in that?
No, sir. Instead of the value, there is no predefined function values. So I have used public value I have given above. By doing that, I am getting the only warnings about this function doesn't have view, public view return.
No problem. No problem. Perfect. Good job. No problem. Okay. Please answer 33056. And 1 second, let me connect up my mouse. 733095. 733021. 733026. 733035. 733056. 733067. 733084. 733088. 7737004. 7737027. 733007, 733008, 733015, 733018, 733020, 733022, 733027, 733032, 733034, 733041,
Present, sir. 3-4. Sir,
Okay.
3-4 present.
733045. 41 is present.
No.
733045. 733061.
Present, sir.
Okay. 733072.
Present, sir.
733080. 733081.
Present, sir.
733097. 733108. 733112. 733114. 733301. 733303. 17/39. Taha. Mohammad Abdul.
Present, sir.
Afreen. I shall change all this to your numbers, not of your name. Afreen. Mohammad Ami Ahmed. Mirza Asif. Mohammad Azharuddin. Syed Alauddin Bukhari. Missum S. Hussain. Zakaria Iqbal.
Present, sir. Present.
Mohammad Jawad. Mohammad Shoaib Khan. Syed Nihal Hussain Madani. Maryam. Syed Kurram Mehdi. Mohammed. MOHD, just whosoever name is written in this way. I shall change it in the next week to numbers, not these names. Asman Namira.
Sir,
Sheikh,
sir.
you're present. Okay. Sheikh Rahmat. Rahma. Zubayya Rahman. Abdul Razak.
Present, sir.
Syed Abdul Rab. Sajad. Sheikh Sadullah Sharif.
Sir, one second. Because I have got the roll numbers. If you don't mind, can I send you the attendance which are present here? 33, 44, 86. Within 2 seconds, I can just do that one and then I'll post you up. Because in recording, it's coming up. That's fine because I have already seen that 3320. Because when you send me the video, I'm doing up and down. I can find out the numbers. I've already noted down the numbers. That will be very helpful.
Okay, right. But only of the guys who are present here, sir.
Yeah, only of those are present. I'm just noting down. You
sir,
just carry on with that one.
Yeah, 4 5 more only I've got. Sheikh
All right,
Sadullah
today you can do
Sharif.
it except from tomorrow. Next class, I'll do that one. Okay.
Okay. Sheikh Sadullah Sharif. Sumayya. Syed. Tuba.
Present, sir.
Okay. Syed Zainul Labidin. Abdul Qadir Khan Khalid.
Present.
Aslam Khan. Mohammad Muqtadir. Mohammad Samir. Mohammad Rafiuddin.
Present, sir.
Yeah, fine. Anybody I missed out, or when your HOD gives me, I'll cross check with this. I'll mark in this itself. Otherwise, if anybody I missed out, please tell me, because once the clock turns to tomorrow, I'll not be able to do anything. Today itself, before 12 in the night, I'll have to do it if I have to change this attendance. Okay, anything you got any doubts with regard to this? Fine. In any case, today at 6 o'clock, there is an MCQ. Please attend it. And please attend means only those guys whose names are registered in this will be able to attend. If you're not registered in this, you won't have got a link and you will not be able to mark yourself. Automatically, you will be marked, and end of it, like what we have done during the previous session, you will come to know of your marks, where you stand. We'll have many more such tests, many more such kind of projects, small little projects, mini projects, and other things, so that the aim is not to fix you. Aim is to see that by the end of it, you are really good in this concept of blockchains. You know what the world is speaking. Okay, anybody, any doubts with regard to what we have done today?
When will you send a download?
Evening. By take another 1-2 hours more to form up into MP4 file. Then I'll share the link of this on the canvas. You can download it. I'll give you time till maybe tomorrow morning. After that, the recording vanishes. So in that interim, may please download it. Thank you, friends. We'll meet up the next Friday.
Sir, sir.
Excuse me, sir.
Yeah.
Hello.
Tell me. Yeah. Tell me. Who spoke out now?
Sir, I spoke out.
Yeah.
Actually, sir, my mic wasn't working. I'm trying to use the thing. So actually, my roll number is 4, and I missed out while you were calling. My mic isn't
No
working.
problem. Just
Actually.
drop a mail to me. I'll mark you. No problem. Thank you.